and welcome to this video that made by Umbrella.co. My name is Muhammad Farhan, head of the Umbrella.co. So I would like to introduce that the Umbrella.co is a company to produce methanol from bituminous coal. Our objective is producing methanol from a fixed feed, which is 5 ton coal per day. Our feedback from a company from Canada run by the Cape Breton Development Corporation (CBDC). A lot of equipment rentals and utilities consume a lot of power. The next slide show the energy balance for every unit. In this cold water slurry, there are three units which which have its own energy. One is compressor, one the other one is compressor to reduce the pressure for the water, and there's a unit for cold water slurry. As you can see here, the water the compressor used to reduce the pressure of the coal, which is produced 2.493 kJ per hour. Next, the second compressor used to reduce the pressure of the water, which produced 2.7905 joules per hour. The next unit is the cold water grinding, which to increase the temperature from 25 degrees Celsius to 90 degrees Celsius, which produce energy of negative 7 exponent 9. Next, the air separation unit is operate at ambient temperature, which is the pressure, which is the temperature of the outlet stream equal to inlet stream. Hence, the energy on this stream, uh, there are no energy transfer in this unit. Next, the entering flow gasifier is used to burn the coal, which the coal is fed with the water and pure oxygen. In this gasifier, the fractional combustion C equal to 99.5%. The ratio of pure oxygen to coal is 0.997, and its efficiency as well turn all the ash into slag. These are the reaction in the flow gasifier. So this is the energy, table energy, which use reference state, which is temperature reference at 25 degrees Celsius and pressure at 1 atm. For the phases, we use uh, carbon at solid, hydrogen at gas, oxygen as gas, nitrogen as gas, sulfur as solid. While the slag that made up of a silicon is used as a reference for the slag in solid form. So the energy produced in this unit are Q equal to minus 193077.79. Next unit, the water quench. The water quench used to reduce the temperature of the syngas from 1400 degrees Celsius to 300 degrees Celsius. Hence, the energy balance for this produce Q equal to minus 803,955.40 kilojoule per hour. Next, the water scrubber. The efficiency of the scrubber is equal to 1, because the syngas produced doesn't have a lot of uh, contaminated such as carbon or slag. But we assume that the scrubber only remove the unconverted carbon. Hence, The energy balance for the water scrubber are negative 3000 3 30 37,000 negative 37,288.88 kilojoule per hour.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Aliana. Okay, next, so for COS hydrolysis unit, the acid of fraction is equal to 0.01 kmol per H, and the Q calculated is negative 1.0550 exponent power of 9, positive 9. Okay, after removing the COS hydrolysis unit, which is stream 12, before entering the next reactor, which is the absorption unit, so we have another PRV, which also function to reduce the pressure into 36.42 atm. Okay, and then for the in the H2S absorption unit, we use the solvent which is DEPG solvent. So the DEPG solvent is at the beginning, the temperature and the pressure for the DEPG solvent is 25 degrees Celsius and the pressure is 1 atm. So before entering the absorption unit, the DEPG solvent will enter a heater to increase the temperature into 38 degrees Celsius. Okay, and for this heater, okay, for this equipment, we assume the enthalpy we assume the Q equal to 0. The specific enthalpy and the enthalpy calculated equal to 0. Okay, after entering the heater, the DEPG solvent will further enter a compressor, which function to increase its pressure into 36.42 atm from 1 atm. So, for this part, we use the as the compressor is a mechanical device, so we use the formula delta P over rho equal to negative Ws over M, and we calculate the Ws using the formula. We obtain the Ws which is equal to negative 1859 kilojoule per hour. So next we have, so after leaving the compressor, it will enter the H2S absorption unit from through stream 13. So in this absorption unit, so the references is all the substances again is in gaseous state at 25 degrees Celsius and 1 atm. And after calculate the energy balance, we obtain the Q equal to negative 36.9274. So on.
Hello, I'm Tasnim Ashikin. And now we want to proceed with a compressor. With a compressor that changes the pressure from 36.9 bar to 50 bar, and the work shaft calculated is 24.17 kilowatt. Next, we have a heater which converts the temperature from 38 degrees Celsius to 210 degrees Celsius with the Q value of 90,109.672 kilojoule per hour. Now we proceed with the synthesis unit. This unit's temperature is 210 degrees Celsius and 50 bar. The Q value calculated is in the negative value. Next we have, before we proceed to flash, we have a compressor which converts the pressure from 50 bar to 80 bar, and the work shaft calculated is 33.465 kilowatt. And now the flash unit. The flash unit has the pressure of 80 bar and temperature of 50 degrees Celsius. The Q value calculated is 170,688.461 kilojoule per hour. Now, The last unit, distillation unit. Distillation unit has the value of temperature of 255 degrees Celsius with 60,004.94 mercury pressure. So the Q calculated is 94,264.746 kilojoule per hour. That is all from me. Thank you.
But as you can see, this is a methanol production with given total profit. First, the material we use is coal. With our spending per hour is 52.47, and the annual spend for 330 days operation is 415,555.40 ringgit Malaysia. For the methanol income, for the per hour basis, for per hour, the rate is 264.69 ringgit Malaysia. So for the annual income for 330 days operation is 2,096,352.64 ringgit Malaysia. So the total profit is 1,687,797.23 ringgit Malaysia. So this is the operating cost. As you can see that we use water, electricity, the catalyst for the catalyst and the solvent for the acid gas removal unit. So this is the total for the operating cost, which is equal to 145 100 100 no 1,456,448. Next, this is our cash flow. As you can see that we don't have any money loss, and it create a lot of cash flow throughout the year until 20. And this is the cash flow without capital cost.
So now we have come to the conclusion. The cash flow without the capital cost shows that our plant design gained a high revenue despite of assumptions made. The methanol produced are 120.11 kilogram per hour, equivalent to 951,217.2 kilogram per year. That is all from us. Thank you.